All right, well, this is kind of a review of a type of problem we did a while back. Anybody remember the name of the concept?
Could be the squeeze theorem. No.
No.
It's an abbreviation.
It is. It's 3 letters.
And I'm pretty sure
IVT.
Yeah, good. The IVT.
The squeeze
Yep.
theorem's the one like if this function and this function have the same point,
The same limit.
the same limit, then the one that goes between them has to have the same limit.
Yeah. If we can prove that it goes in between, then it has to.
And then this is just to prove it's like something's continuous because it's all about.
Yeah, good. So it has to be C. If f is continuous, then it has to hit that value at some point. Yep, intermediate value theorem. Good job. All right, well, I'd like to, we have one more example to finish on the implicit differentiation, and then I'd like to move on. How did the problems go? Do you have any questions on them?
No, I just forgot to rewrite them as dy dx.
Okay.
Like I did the derivative of all of them, but I forgot to like get dy dx by itself.
Okay.
We don't have to simplify right after we have dy dx.
Yeah, you just.
Well, it goes back to the usual, like if it's a multiple choice, be prepared to simplify to match what they have, but otherwise not.
But yeah, other than that, it went good
Okay.
for the most part.
Well, we left off talking about the horizontal and vertical. Oh, that was too. Right there. Horizontal and vertical tangents. And we had said slope of a horizontal tangent is 0 and the other one is undefined. So most of it is the same concept as before, but now we just have to know how to find out where those are true. So let's do the quick, for this one, let's do the find dy dx real quick. Don't forget the derivative of a constant is 0. So I think, Aiden, what you said, you had gotten it to this point,
Yeah,
And just
then
not
I just forgot
isolated.
to.
which is a fair bit of the work, huh, sometimes, is that algebraic manipulation stuff. All right, so that's the expression for slope, and then it says find all horizontal tangent lines of the graph. So how do we want the slope to be 0, but how do we ensure that that's true?
It's at the top equals to 0, and right the top is equal to 0.
Yeah, that's the big idea here. So dy dx is 0 when the numerator is 0. So negative 3x equals 0. Okay.
What is lunch?
Today at 10:55. Why are you doing your phone?
What?
Why are you using your phone?
Because I was texting my parents to get my cheese out.
Okay, good.
They were asking what time my lunch is.
Nice. All right. So that's the slope, or where the slope, is 0. We already know the slope is 0, but that's where that's true. So how do we figure out the equation of the tangent line there? Or potentially more than one, right? Any thoughts? Yeah. Find the y value. So this is the x value where there is a horizontal tangent. Okay. So we have two of them, right? And remember that the equation of a horizontal line is y equals. So y equals square root of 8, y equals negative square root of 8. Okay. We could simplify the radical, but we don't necessarily need to do that. Any questions on that? Okay. So find the y values. Let's put a little note here about write it. Let's see. As a horizontal line. Okay. How about vertical? Notice the equation is the same, so dy dx is the same. So what is true to make that undefined now?
2y equals 0.
Yeah, so the denominator, right? Okay, and then what are we looking for in this case? What is the form of equation for a vertical line? X equals, yeah. Alright, so we just solve for, solve for x. So 3x squared equals 16. And I think I'll just write those out. What? Did you say that? Oh. And you could square root the 16 and make it 4 over square root of 3. Alright, any questions on those? Seems okay, right? Okay. Big idea is just knowing how you get the slope either 0 or undefined. And of course, making sure to do your dy dx correctly. So I don't want you to do this now because I want to do the next section, but in your packet, go ahead and definitely want you to do these. Would you rather practice natural logs or just regular? Let's do a natural log one. So 15. And let's do a trig one. And 19. So just those odd ones. You guys remember what normal means?
It's the opposite. The
Yeah.
amplifying. Or I guess the slope is.
Opposite reciprocal. There we go. Slope. Okay. Just do that one, the normal line one on that. Any questions on those? I think you mentioned that this weekend you're not planning to have time to do anything, right? So, okay. So we really just have today and tomorrow. When do you guys get back? Saturday night?
We leave Sunday morning.
Sunday morning, okay. So yeah, you really probably won't. You'll be wiped out. Do you want to shut that or is it bothering you?
No, it's good.
Okay. Alright, well, we'll just see how far we can get in this and then pick up with it when we get back. So this is interesting and kind of weird. So inverse functions, I'm taking the derivatives of those. We will split this into, so today is derivatives of just inverse functions, and then we'll do inverse trig functions tomorrow, depending how things go. So this is a memorization one, but let's quickly remember what does it mean by an inverse? You guys remember from either algebra 2 or pre-calc? Or like, what's kind of the idea behind inverse?
It's like the inverse of a function is like the y values and the x values of like the y values of the original function is the x values of the inverse function.
Yeah, good. So swapping input and output. And do you remember to find one, we switch x and y?
Yeah.
And then isolate the variable. And it's a little bit confusing now because we've seen this x to the negative 1 means 1 over x. But f to the negative 1 does not mean 1 over f. It means the inverse of f of x. So you have to use context to know this, right? Yeah. And we say f inverse. Do you remember that? Okay? So we could use a different function and just define it to be the inverse. You'll see that as we do some problems and in AP stuff. So g of x is the inverse of f, or maybe it will say g of x is f inverse of x, and it will give you the notation. Okay? Do you remember also that if you plug inverses into each other, they both simplify to x? Do you remember that? Okay. Maybe just take note of that one and say that reminder. In fact, that was one of the ways that you could check to see if functions were inverses. So, anyway, so the derivative of an inverse, you're just going to have to memorize this, which means the more times you write it, the better chance you have of memorizing it. So this is a fraction, 1 over, and we'll use the prime notation. I'm going to write it out and then I'll tell you what it means. So 1 over f prime, or dy or df dx, of the inverse function at that point. The inverse function's value at that point. So the typical process for this is figure out the inverse. If you're given it, you just figure out the value when you plug in the point. If not, you have to figure out the inverse and plug in the value. Then take the derivative value of that value. So we now know how to do the derivative of a lot of stuff. So that part should be fine. Okay. Any questions on that formula? Okay. Again, the more times you write it, the better off it will be. So the table gives values of differentiable functions at selected values, and so it says let g be the inverse of f. Okay? So what is the value of g prime of 1? I would, and this is just a suggestion, but I think it will help you. I would rewrite g in terms of f. So g of x, I'm just right now just copying what we were told. Because that means we can, it's really finding f inverse of 1, right? And that way we can keep our notation kind of a little bit simpler. Well, consistent anyway. Okay. So we're really thinking of this as f inverse prime, right? It's kind of, so we don't want to use prime notation for that. So we want to do dy, or sorry, df rather, df dx of f inverse of 1. That's kind of how we're thinking of this. Any questions so far? There's a lot of stuff notation-wise floating around in here. Well, Our formula, that's what I was trying to point to. 1 over the f prime of f inverse of x is how this looks. So again, write it out. I put brackets up there, parentheses are fine as well. Okay, I'm just going to change this little x to a 1 so that our notation matches. And there we go. So what is f inverse of 1? Well, if you notice at the in the table, we don't have f inverse. So it goes back to that top statement of switching x and y or swapping output and input, right? So f inverse of 1 means what? What are we really looking for?
Y equals 1.
Y equals 1, yeah. Okay. So we go here, 1, and we look for f inverse of that, which means 2. Everybody good on that? It's a little wonky, but are we good? Okay. And then we do f prime of 2, which we do have directly in our table. So this becomes 1 over negative 2, or just negative 1/2. Make room for that negative sign. Okay. Kind of interesting, huh? We've seen multiple examples of these tables where we have to like shift values around, which I think is kind of cool. All right. How about this other one? You want to try it? Did you do it already? Okay. Did you?
No.
Okay, let's give you a second to try it. All right, well, we already did the slope. Which was negative 1/2. And we're going to plug into this like we usually do. So, but how do we get these to correct for, this is what he was bringing up a second ago, for f inverse, what is actually the x and y?
Would you plug in 3? I don't know.
I'm writing it this way. X is y and y is x. Okay? So for f inverse, this is our x and this is our y. So this should say y minus 2 equals negative 1/2 x minus 1. Did that answer your question?
Kind of. Why isn't it the one at the top though? Like the at x equals 1, because technically like that's still at x equals 1, but your inverse equation would be 3, like your inverse would just be flipped.
Well, but if we
Or you have to find where that value is 1, like where your y value is 1.
yeah,
Okay.
because if we flip these for like all these problems, this is going to be f inverse and this is going to be x.
Okay.
Right?
I get you.
Anyway, how'd that go? It's confusing. I totally agree with you. All right, let's do these. That's good enough. All right, so let g be a differentiable function, and it gives us a bunch of values for g and g prime. The function h is differentiable also, and h is the inverse of g. So what is the value of h prime of 6? So kind of similar to the table, only it's just given more in a sentence form. I still think it's a good idea to operate under one or other of these, so like G prime. And I like to use G prime instead. So H prime is the same as d dx of G inverse, in other words, right? Which is 1 over G prime of G inverse of x. All right, so G inverse, this again, you have to look at this going backwards. So we're at 6, so we need to plug in G inverse of 6. So we need to look at 6 and pull the x coordinate for that. Yep. I'm writing a little bit more on these just because it takes some explanation. So x is 3, and then find G prime of 3, which is -2. So our H prime of 6 is -2. Okay. Any issues with that? Okay. I said, by the way, I said it wrong. I said -2, I should have said -1. But I wrote it, I just said it weird. Alright, last one. How are we doing? No, it's not. This one's a little bit more involved. So I hope I have enough room here. I'll just try it. Alright, so if f of x is given there and g is the inverse, what is the value of g prime of 25? This time we have no given values. So we're going to have to find the inverse, this part inside our denominator, we're going to have to find the value of that. So g of x equals f inverse of x. What is f inverse of x? You guys remember how to do that?
Yeah, you just swap x and f of x.
Okay, yeah. So I'm going to write it as y for now. And then we just solve for the y. So x minus 1, and then divide by 3, and then cube root. Okay. Now you can, I've told you this before, and you're going to have to decide how you are as a calculus student. I tend to work in the symbolic and then plug in numbers at the end, but you can do this without that. You can plug in numbers as you go as well. So you'll have to decide how you want to do it. Anyway, so we have our inverse function. So d dx is the same as g prime. In fact, let me write that just so we keep everything clear. G prime of x is the same as d dx f inverse of x. Okay. And then we just have to figure out some numbers to plug in here. And we're doing, where are we doing this? 25. Okay? So f inverse of 25. So now I'm going to write g prime of 25. Okay. So we plug 25 in here. 25 minus 1 divided by 3 is 8. Cube rooted is 2. So this becomes 1 over f prime of 2. Well, we don't have f prime, do we? So we need to get f prime, not inverse, but just regular f. So 3x cubed plus 1 is 9x squared. Okay? So df dx is 9x squared. So basically plug in 2 into that in the denominator. One over 9 times 2 squared, which is 1 over 36. So just a little, we had to do two things. We had to find the derivative of f, just regular f, and the inverse of f this time, because we weren't given values in a table or in a list like the last one. So a little bit more work. Any questions? Did you do okay with that?
Yeah.
And that's kind of inverse. Notice, in terms of finding the inverse of a function, or excuse me, the derivative of an inverse, multiple times we were just told that this function is the inverse of that one. And if it's, other than this last one, where we weren't told that, I mean, we weren't given an inverse, we had to actually find it. But some of these problems you're just told, here's the inverse. So it does save you a little work.
Or it would be like an FRQ problem.
Yeah.
If they had it.
Yeah. I agree. This would be like an FRQ where you would have to show your steps to getting the 136. I could also see them putting that as an in-context problem too, and using, kind of like we did, like using the slope to calculate some rate of change or something. Yep. So there's a lot of opportunities in a problem like that last one to mess up. So you just have to take your time, pay attention to those details. In terms of which ones to do, definitely want to do one like that. But AP likes the table ones. I think those are good. Just for fun, look at number 15. Tell me what all would go into the derivative of g. Just like finding dg dx.
Well, you'd have to,
There's a 2x in the square root.
Yeah, chain rule. How do you find the derivative of a square root?
Just 1 over
1/2 times
Root, whatever.
root of that. And if you don't have that, you can just say that to the 1/2 and then do the power rule backward.
Yeah. How about cosine? What's the derivative of it?
Negative sign.
Negative sine. I feel like we haven't looked at those in a little bit. So, okay. So why don't you circle problem 5, 5 and 6, and then and then do 13 and 15. And we'll start with those since there's problems from the other packet. Okay. And see how it's going tomorrow, and then we can determine what to do from there. Are you guys excited?
Yeah, I'm sorry.
Yeah.
Ready. I mean, actually, I'm ready, but like, haven't even started thinking about packing.
You guys have to. I would imagine your outfits take up kind of a lot of room in a suitcase, don't they?
We put them in a trailer.
Yeah.
So we take 3 trailers with us and then 2 bicycles.
Oh,
We have a little trailer.
yeah, you do. But you like your suitcases and instruments are in the trailers?
Those go on the
Those
bottom
go
of
on
the
the
buses.
Yeah, okay.
and then uniforms go in the trailer.
Yeah.
Oh, probably like hung up so they're.
They go, they're hung up.
Yeah, okay.
So they don't
So
get
they're
them.
not wrinkled.
Well, my instrument goes in the trailer. It's not gonna fit on the bus.
Yeah. But you guys, will you have it like just underneath the bus or with you in your seat?
So yeah, it'll be underneath the bus. They have like little
Okay.
like, storage underneath the buses.
Is it school buses or the nice kind?
It's a nice.
You guys, that's awesome. That's so much better.
It is so much better.
Driving to Colorado Springs on an activity bus is not it.
Man, that's what I used to do in high school. I only traveled a few times for music, but for sports, we would just take a regular school bus like 6 hours away.
Yeah.
It sucks so bad.
That's what we did for our our Skyline trip last year and the year before. We
So
just
that's
took
in
one of those
Denver. No, that's
activity
in
buses.
Salt Lake, right?
Skyline? No, that's in.
Well, there is a Skyline in Salt Lake.
No,
Yeah.
it's the one, it's next to Loveland.
Okay. That's a long way.
I feel like the activity buses are even more uncomfortable than the actual school buses.
Yeah.
Are those the little white ones?
The little
Yeah.
white ones.
I've
So
never
like
ridden
anyone
one of those.
with a driver's license could drive those.
Really?
Yeah. Snow drove it.
So Snow drove them. He's,
We made good time.
he definitely, yeah. He did not.
We made really good time. Especially the year before last year. Last year he had, because the year before, I guess, like, I don't know, he went too fast.
Oh, did he?
And he didn't know that there was like something that like monitors your speed.
Oh, I've heard that. Yeah, they like communicate with you and tell you.
So the year before last year, we got there quick.
Did he get in trouble?
I don't think he got in too big of
Didn't
trouble.
he get in trouble for you guys not wearing your seatbelts?
Yeah, he did get in trouble for the seatbelts thing. So now he has to yell out seatbelts every time we.
I didn't know those had seatbelts.
They do, we just don't wear them.
Yeah.
Yeah, because my son just, like, I told you he had to go to Durango on the steamboat. And he showed me a picture of several guys, like, laying on the floor and across the aisle and stuff.
Yeah.
Yeah. I'm sure they took one of those white ones. Actually, I know they did. I saw them get on.
Yeah.
Snow's a pretty.
If he gets caffeine in his system, he goes pretty quick. Goes pretty quick.
Well, it's cool. It's exciting.
Alright, see that thing. It goes pretty quick.
So you have 2 big buses?
Yeah.
Yeah.
So when would finals be if you do
It'll be the same day as semifinals.
Same day as semifinals.
That's just later in the afternoon.
So, like, let's say you make it to finals. Do you, like, go back to your motel and eat or anything?
Once we're gonna like find out if we're making finals, and then they announce the time that we're performing, and depending on that time, we're either gonna stay for a little bit, watch a few finalists, and then go to warm up, or if we're like one of the first, we're gonna immediately go warm up, and then like,
Yeah.
So do you have snacks and stuff, or do you just not?
yeah, we have snacks. They also have food.
Oh,
Like bankers have like meals that they cook for us.
that's cool.
Yeah.
All right, well, I'll see you tomorrow.
I will see.